Okay, so we're going to be doing an inequations question, one where there is an absolute value on the bottom of a fraction. There isn't two absolute value signs, there's just one absolute value expression. And this whole thing, 1 over absolute value of x plus 1, is less than 3. So the first bit to get started is we need to split ourselves into two cases. One where it would be a positive value, so it would be a positive case, and one where we'd be going with a negative case. And with both of those, we just remove our absolute value signs and we would have one expression that looks exactly the same. So that would be like this: 1 over x plus 1 is less than 3. That is our positive case. There is no change to the inequality sign and there's no change to the sign of this. Our second case that we would be making is 1 over x plus 1, but then we would be changing our inequality sign and making this a negative. Why? Because if this was our negative expression, it would be a negative magnitude on the other side. Let's say if I was drawing a line out, I would be a certain distance away from 0 if it was a positive case, but if it was a negative case, I'd also be the exact same magnitude or distance away from 0. It doesn't matter that it's the negative side, I would just be the same distance. This is the same and it is both a positive distance away from 0. So that's where we are making these two cases from. So all I would need to do is I need to make up an initial condition. An initial condition that we're going to work with the entire time. And I should have set an initial condition up here, which we will set in a second, but for this one, if I'm saying that this denominator was a positive expression, not positive x, but a positive expression, I could rewrite it out as x plus 1 is greater than 0. And the reason why I'm stating that is because I've said this is positive, and this is now showing that x plus 1 is greater than 0, meaning that it is any positive real number. And then I can rearrange for it, saying that x can be greater than negative 1. So for this to be a positive expression, x has to be greater than negative 1, which means x could technically really be a negative real number bigger than negative 1, or any positive number. If I'm going over to my second one over here, which is my negative case, meaning the expression is a negative case, we would be going with x plus 1 is less than 0. And that is because x plus 1 is a negative expression, meaning it can be any negative real number that is less than 0, which any number less than 0 would be a negative real number. And we can rearrange for that as well. So x has to be less than negative 1. So on this side, only negative values can apply. X can only ever be a negative value, whereas over here we have the potential of there being a positive and a negative value. My initial condition I should have said at the top was we have to have some sort of value of x that will not work. And my value of x that will not work is when x, I'm running out of a bit of room, cannot equal negative 1. And the reasoning is if I have negative 1 plus 1, that provides me with an answer of 0, magnitude of 0 is 0, but then I have a denominator that is 0, and I can't divide by 0. So there's always that case, x cannot be negative 1. So we've already got these three conditions that must be met. When I follow through on this side, this initial condition must be met, but it must also contain this one. When I follow through with this one, this initial condition must be met, and if it is, we'll also be meeting this condition, because you can notice that both of these alternate around that negative 1. None of them say that we can have an x that equals negative 1, which is so far so good. So we're going to go with our positive case thing over here, and we're going to go back with 1 is x plus 1 over 3. So these initial conditions, I think, is where some people are getting stumped. It is a condition that we are making, and we are setting that up. So once we get an answer, we need to see if it aligns with our condition first. If it doesn't align with our condition, instantly we know we have a problem. So I'm going with this: 1 over x plus 1 is less than 3. And we can rearrange for this value. Now you'll notice that my inequality symbol did not change because this is not a negative expression. We already know it will be a positive expression. We don't know that x is positive, but we know the expression is positive. So I can expand that out. And we can start rearranging for x. So if I was to minus the 3 over, I would get 1 minus 3, which is negative 2. That is less than 3x. It can be stated that x must be some number that is greater than negative 2 on 3. Now, why is this the case? Because if I was to substitute in any value here, as in negative 2 on 3, I can show it off to the side here. If I was to put that as a case, negative 2 is 3, negative 2 on 3. The 3's would cancel each other out, leaving me with negative 2 is greater than negative 2, which is incorrect. Right? That does not hold. Negative 2 cannot be less than negative 2, they must be equal. So I have to make a statement that if I was to do something that was just slightly larger than negative 2 on 3, so let's do negative 1 on 3, I would get negative 2 is greater than, is less than, if I do my times by 3's, they cancel out, leaving me with negative 1. Negative 1 is greater than negative 2, which that statement holds true. So for this, negative 2 on 3 must be less than x. That is, x must be a value that is larger than negative 2 on 3. And we can check this. And we should always check all of our solutions along with graphing it. So, if you ever come across a problem where you're unable to rearrange, where it would provide you with a wrong answer if we were to rearrange, and that's due to the statement of x could be positive or negative, has an effect on this particular section, we can make a statement here that x must be greater than negative 2 on 3 for this one statement to hold true, because every one of our statements as we progress must also hold true. So let's check this for, or we technically just did check it, but let's check it for a different value. Let's check it for when x is 0. That is a value of x that is greater than negative 2 on 3. So let's sub x equals 0 into 1 on the magnitude of x plus 1 greater than 3. We need to check it with our original statement that we made right at the top. So if I'm to substitute that in, it'd be 1 over 0 plus 1 less than 3. 1 divided by the magnitude of positive 1 is 1. That is, 1 is less than 3. It holds true. So, statement is true. Therefore, x must be greater than negative 2 on 3. And we can then graph this. We're also going to go with our negative side before we start doing our graphing. So we've also got this one that x must be less than negative 1. So we're going to do the same thing. We're going to go up into this equation and rearrange. And remember, that bit that we've made here, x greater than negative 1, or x less than negative 1, is just an initial condition, which we should be checking. So let's have a look at our right hand side. Our statement was that x is greater than negative 2 on 3. And our initial condition was x must be greater than negative 1. Well, our statement is x has to be greater than negative 2 on 3, which is greater than negative 1. So our initial condition is already met. So let's hopefully get our second one to do the same thing. So we're going to substitute in, and we're going to rearrange. I don't really need to do a fraction there, but I'm going to just show that this expression is a negative expression. Let's make sure that we are understanding that this is all a negative expression for this particular case. So if I was to do that, this would flip my inequation symbol when I multiply through. And that would leave me with a expanded version of that statement there. And then we can rearrange to get x by itself. So we would plus 3 on this side. And then we would divide by -3. Which causes me to flip my inequality sign because I am dividing by a negative number. So my statement is that x must be less than -4 on 3. So let's check with our initial condition. Our initial condition was x must be less than -1. This statement says x must be less than -4 on 3, which is 1/3 more, or 1/3 in the more negative than our initial condition. So our initial condition is successful. So all we need to do now is check, and then we can start to graph things. So my checking is when x must be less than -4 on 3. So how about we try -2. So we're going to substitute it in. So every single place where I would usually have an x in my original statement, I would have a -2. And again, we're going all the way back up to our original initial statement, which is up here. And then I would solve. 1 over the magnitude of -1 is less than 3. Magnitude of -1 is +1, so 1 is less than 3. The statement again is true. Therefore, x is less than -4 on 3. So now we're able to graph both of the statements, which is x is greater than -2 on 3 and x is less than -4 on 3. So we can start to draw up a number line now, going into the positive section as well as going into the negative section. And so I had two values, one of x being larger than -2 on 3. So we break this up into thirds and we can find -2 on 3. I do an open circle indicating that it's not that value, but my arrow indicates that it can be anything above that section. And I also find -4 on 3 and do an open circle, and it can be any value that exists below that. So for my overall equation of 1 over the magnitude of x plus 1 greater than 3, I can have any x value that is in the range of greater than -2 on 3 and less than -4 on 3. And that meets my initial condition of when x is not equal to -1, as indicated by the space in there.